Yeah, this is for the free.
Okay.
Yeah, well, welcome everybody to the third Docker and Kubernetes Meetup. Right? My name is Vasu, and I have two helpers with me who try to organize this setup, and that's Adele and Pavel. And just because this is a... Yeah, but Pavel and I do work for SAP, but this is not an SAP setup. It's really on private time and so on. And we are somehow listed at the Cloud Native Computing Foundation, and indeed will hopefully get sponsored by them soon. I heard that there are new possibilities with respect to sponsoring, and therefore we also want to make you aware that there are actually discount coupons or discount codes for some courses around Cloud Native. I think if you're interested in this stuff, this might be a way to get actually certified. And I guess how long are
end of the week we have 2 days left.
Yeah, 2 days left. Take note of this. This might be interesting for you. And without further ado, we also want to thank our sponsor, Martin, who's helping us with the rooms here. And actually, we also have pizza.
I'm not sure what's the food, but there should be something for food later. So, hi everybody. Words of welcome from Sovanta. So I will just quickly introduce ourselves and tell us what we do and why are we today hosting this meetup. So we're a small company. We have about some 10 years in the business. We right now have about 200 employees, and we have offices here in Heidelberg, as well as in Hamburg and in Buenos Aires, where I come from. We focus on building software solutions and improving business processes. And we have customers in areas such as HR, CRM, real estate, logistics, e-mobility, and smart living. To these customers, we deliver both custom-built solutions as well as preview solutions based on our existing technology stack. And we also offer them design thinking workshops, and we focus on user experience design. And since a couple of years, we started a data science department as well. This brings us to what we actually use for our day-to-day work, our technological stack. We have a very varied stack, so we are using native technologies such as Objective-C, Java, and React Native for mobile development, as well as C# for desktop development. We use web technologies such as Angular, Vue, UI5, and Elm for different front-end technologies. And in the backend side, we are using ABAP, we have components in Java, we have C# again, we have Node.js, and Python for data sciences. So having such a broad scope of technologies, that means that when it comes to deployment, we need to be able to keep a lot of flexibility, because some customers want to deploy on premises, some customers want us to deploy their product for them, some customers want to use different cloud providers, and in order to keep a flexibility and have something that allows us to deploy in different environments without basically making our lives more complicated, we ended up using a Docker and now Kubernetes as our deployment infrastructure, which is why we are now hosting the Docker Meetup. All right. So as usual, we're always looking for speakers for the next meetups. So if anybody is working on any of the topics, and at the end we are going to show like a broad spectrum of different stuff concerning different cloud technologies, then we're always welcome for you to speak up. And also, if you can offer your own space to host the future events as well. And we would like to thank our first two speakers. So I will quickly introduce them. First off, we will have Timo, who is the CTO and founder of Giant Swarm, and he will be speaking about microservice architecture on Kubernetes. And then we will have Alban, who is the CTO and founder of Kingwalk, and he will be talking about using BFP in Kubernetes. So I think with further ado, we can start with our first speaker.
We will have a break in between.
Yes, we will have a break in between. There are toilets around the corner. And if anybody needs to get something to drink, there is a kitchen. They can just have to serve some water, and then we will go over there for some beer.
Perfect.
Yes. Yeah, just
Phone and camera. So hi everybody, I'm Timo. I'm coming from close to the Dutch border, near Cologne. Giant Swarm has a headquarter in Cologne, but we're actually a fully distributed team. And just to give you a short intro of what we do, because I don't give a product presentation,
I don't want to give a product presentation here on such a meetup. We run Kubernetes clusters in the data centers of our customers. And to do that, we are kind of building our own Kubernetes distribution. At least that's how we are listed in the Cloud Native Foundation. But we don't consider ourselves a distribution because we want to provide a vanilla Kubernetes setup. So in the first place, we said if it runs on Minikube on your laptop, it needs to run on ours. So it's not that we like have a managed master and you cannot do anything with it. You have like full root access to your Kubernetes cluster. But obviously, in the enterprises we work with, those clusters are locked down quite well by the departments who manage those clusters, and the developers mostly have CI/CD systems to actually deploy to the Kubernetes clusters. But yeah, we do this on-premise in the data centers on bare metal, but also in the cloud accounts on AWS and Azure. And yeah, we have a couple of hundred Kubernetes clusters that we manage actually across the world, and we're now having the first installation in China, which is an interesting challenge if you have ever done that. But yeah, and we have customers like Adidas and Vodafone, and yeah, we run their cloud native stack, which is in the first place was Kubernetes, but now it's getting more and more. So we run have like monitoring stack, Prometheus provided, and a logging stack, and we're just like building up more and more of these cloud native projects, the open source projects that are located in the foundation, and yeah, we help the customers to be faster and to have their developers ship their software faster. And yeah, I said we're located in Cologne, but actually we're not. We're in 12 different countries with 25 people. So we're fully remote, and from time to time we meet, and it's a lot of fun. So that was in the winter, and we went to do some Nordic skiing and some biathlon. So we learned how to shoot like in the middle of a snowstorm. So that was kind of funny. And yeah, and we decided that pretty early on because we thought the people we're looking for are not all located in Cologne, and we also don't get all those people to move to Cologne, and that's why we are based in Europe. So we're basically in one time zone, but all people are remote. And I'm also not driving to Cologne anymore to the office. I did this in the beginning, but there's no use to drive to Cologne and then be on a chat with your colleagues, and I can do this from home. Yeah, so what do I want to talk about? First, maybe a bit of understanding who you are. So who's running Kubernetes in production? Nice. Who of you is Kubernetes operations, and who's Kubernetes user? Kubernetes operations? Both? Operations and user? Okay. So yeah, I created this talk in the first place for a microservice conference, and that was heavily focused on architects and software developers. So I might skip through some of the slides if it's not that interesting for you, and maybe talk a bit more about the operational part because that's what we do. But we are also Kubernetes users because the control plane that we provide in those installations is actually Kubernetes. So all our services that are managing the Kubernetes clusters, because we're not manually managing them, it's software that manages all those Kubernetes clusters. They are running in Kubernetes as well. So we're basically a user and an operator of Kubernetes. So yeah, brief overview of Cloud Native. That's pretty boring. Then I want to go through step by step what is necessary for services running in Kubernetes, what does Kubernetes provide, how can you extend Kubernetes, and then what else is in the ecosystem and why does it fit so well together that there's a foundation that like puts all these software projects together. So Cloud Native. So first time I heard this, I was like, what the fuck? I don't need another buzzword. And actually, most of that, what is in there was already in microservices for me. So and you know, if somebody mentioned microservices, my ears started bleeding anyway. So yeah, what does it mean? I mean, it's software that is built for the cloud, and it's scalable, and usually it's microservices. They are small. You probably all know this. And for me, there is, I mean, these are the projects. You know them as well. For me, the small parts basically or mainly for unblocking teams. That the teams are just independent. They have their story. They own a business story, and they can ship. They can do that without being locked by another team. So they don't have to wait for the other team to implement a component, because the business story is spread across teams, and everybody is just developing components, right? So you build your own small components that are just necessary for yourself. And that makes you faster, you can iterate, and so on, and you can also experiment. I don't know. There's an example like Airbnb does like 2,000 experiments a week or something like that. So A/B testing of those, right? And you can imagine that you can, if you iterate that fast and test things that fast, you can just take better decisions. You're faster, you innovate more, and yeah, it's just obvious. And the cloud native part for me is actually that yeah, that everything is declarative. That I don't write bash scripts or something like that, and I consider Ansible a bash script basically, because it's YAML, but it's executed one by one, so it's a script. It's not a declaration of something. At least I've never seen anybody using it like a declaration. And yeah, immutable infrastructure, which is very important if you want to have fast failover, so a very low mean time to recovery of your systems. And I mean, Docker made this clear for everybody. And, you know, it's just it was just amazing to see how fast you can start up a service and or replace a service. And yeah, and the other thing is the building blocks. Like you can see this during the talk, that those things, the concepts, the resources that Kubernetes provides, and then the things that come on top, they all play nicely together. So they are kind of building blocks. And you can always go down to use a single pod. If you don't want to have a replica set, or you want to write your own controller to write some workload, a different pod that is not covered by Kubernetes at the moment. I mean, in theory, this can still happen. And the thing is, when I focused set this in like 10 years of AWS, it's important to build those kind of building blocks and then go higher up the stack. And you can see that you can still run, start your EC2 instance, but you can also use many services on top that underneath use EC2 as a service. And I think that's also built in the cloud native software projects. And Kubernetes got this right for me, so that's why I believe Kubernetes is the right choice for me to run an infrastructure or a platform on top of Kubernetes. And yeah, lots of people say open source is not a lock-in. It's a lock-in, but still it's a community and a multi-company lock-in that I prefer way much than having a black box by a single vendor. And that's why this is like my personal core belief. It's a lock-in if you use Kubernetes, because you won't get rid of it very fast if you bought into it for a couple of years. But still, it's provided to you by many vendors, and it's also like if you as a developer or ops person move to another company and they are using Kubernetes too, it's just it's for your own benefit that you know the system already and how it works, and instead of having in that company having something from I don't know, Cisco or from SAP, and in the next company, something from IBM, right? So that's a benefit for me. So what do you need to run services, like in general, not necessarily on Kubernetes? You need some configuration, you need some secrets, you need to somehow register the service, make it discoverable, you need to find other services, you kind of need to provide some metrics of that service, you need to have logs. If you have many of those services, you definitely want to have tracing because the complexity is getting higher and higher with more and more services. And then, yeah, typical microservice things are things like circuit breakers, authentication, authorization, yeah, and that's what you need for every service. And now I want to look at what the projects provide you to actually do that and how that works. So yeah, that's the thing that you might have realized if you have many microservices and, for instance, use something like Spring Boot as a library that helps you creating those kind of microservices. A lot of those features, or a lot of those things I mentioned, you use for every service, are covered in those libraries. And if, I don't know, maybe the team that does the monitoring wants to change something in the monitoring, you actually need to change configuration in all of your services, in the worst case, right? And then you actually need to rebuild all the services because it's a library, so you actually need to rebuild all the services and then redeploy all the services. And that's a challenge. It also means if you want to use something for in Python because you want to do some data management, or if you want to do something in Node.js because JavaScript is just the choice for something that is close to the web front end. And then you need to reinvent the wheel within the service again. Like in Java you have that already, but then you need something that does something similar in Python or in JavaScript. And how do you deal with software that is legacy or not written by you? That, like, how does this piece of software integrate with the rest of the stack, right? And that's a general problem I see with shared code. And so now I want to try going through all the projects and explain how those projects actually replace this kind of shared code with concepts that make the services independent from that. So all this cross-cutting functionality that you need for every service is kind of provided but attached, and you have a polyglot stack, and you don't need to reinvent the wheel. You still maybe need to talk to the Kubernetes API and have a client that does that, but all these typical things that I just mentioned are kind of covered already. So yeah, as I said, the declarations in Kubernetes, you have manifest. I mean, we can skip through that very fast. You have lots of different resources that offer you the building blocks, and an example would be having a small service that's a deployment. So a deployment is a resource that then by the controller would be picked up, and a replica set would be created, and the replica set would actually create a pod, or how many replicas you want to have, right? So it's kind of a delegation within the Kubernetes resources. You have a concept deployment, you have a concept replica set, you have a concept pod underneath. And yeah, you can attach configuration to that deployment through a volume, through a config map. So you define the config map, and then you get your configuration. Same for the secrets. And so the thing is, you don't need to know anything about this within the service. You just have a file. So POSIX is your interface, basically. And the integration with the load balancer. is actually, or with the service discovery, is actually a liveness probe that tells Kubernetes if the service is alive. So if that doesn't respond anymore, actually Kubernetes would kill the pod and recreate the pod just to try if that helps. And the other thing is you can also provide a URL, an endpoint with readiness. That means you have under control if you receive traffic or not, but you won't get killed. So in the case that you start up and your service needs some time until it's ready, you provide this endpoint, and until this endpoint is healthy, Kubernetes would not send any traffic there. And then you can, if you have multiple pods, you also want to load balance across those pods, and you have a concept called service to do so. And the selector is the label that was provided earlier in the deployment. So there's a label my service, and then I create a selector my service. So you can actually talk to that service, and the service would round robin across the pods. So that's another abstraction, and it's not actually not really a container or something that runs in it. It's just a virtual concept that then, like the kube proxy, will do the routing for you. And another project in the foundation is Core DNS, which replaced kubedns that was there before. And so you can also talk to the service through DNS, which is most commonly the way how people use service discovery in Kubernetes. So these are the things that Kubernetes provides you out of the box, and I don't have to use a library for that within a service. It's just attached to my service, and I'm fine with that. Maybe you never had this problem, but people who are running microservices with the Netflix ecosystem and older systems, they definitely know those kind of problems of shared code and having libraries and such. Yeah, I mean, there are tons of resources within Kubernetes that you can use that provide even more. So in the end, with all these resources, you end up with a lot of manifests that actually create your service. So a way to bundle those manifests up to an application is Helm charts. So you can create a chart that is basically a templating system for those manifests, because if you want to run a service in deployment, in staging or in production, you probably need to change some of the configuration. So there's some templating built in, and then there's a small service running in the cluster that actually creates the resources in Kubernetes. And there are registries like Quay.io, for instance, that supports storing Helm charts in the registry. So you have not only a container registry, but also an application registry where you can push the chart into the registry, and then you can also watch a channel, for instance. So if your deployment pipeline, and actually have a drawing of an early version of our deployment pipeline. So if one engineer merges a pull request on GitHub, actually Circle CI build would be triggered, and once tests are fine and stuff, the container is built, the containers and the Helm chart are built, it's pushed to Quay, and then Circle CI notifies GitHub with a deployment event, creating a deployment event, and then we have a daemon running in the Kubernetes cluster, because we have lots of clusters that are actually in data centers behind firewalls, and you cannot push something in there. It's just only pull works there. So the draughtsman would actually watch the GitHub events and then tell Tiller to fetch the application from Quay to deploy the new version of the service.
How do you do this in China?
How we do this in China? Actually, so GitHub works. Way not. I think Waze it works as well. In the first place, we thought Quay is not working, but I think it works now. And also the connection isn't that bad to get the containers over there.
Because in the first place, thinking about a central setup and not replicating something into the region of China.
Sorry?
You're not thinking about replicating all the GitOps into the local geography.
No, actually, China is pulling from Europe at the moment. But I'm not in the team that, so I don't have exact details. But at the moment, we're actually fetching from Europe. Yeah.
I hope questions are okay.
And yeah, definitely. And I'm not sure if we had another peering agreement to have a better connection, because in the first place it looked quite bad, but I think we're fine now. Mm-hmm. But yeah, no details. Other questions? Okay, so next part is, because we do a lot of infrastructure, the concepts in Kubernetes are quite well to do operations of infrastructure. We also started extending Kubernetes a lot. That might be specific to somebody who's running infrastructure, and I don't know, if you build your new shopping cart system with lots of microservices, you might not extend Kubernetes for that. But still, I just want to give you a bit of an overview how you can do that. So yeah, I mean, Kubernetes basically stores everything in etcd, and etcd is, the important part is that it's consistent, what is stored in etcd, so that's my source of truth, right? And you have a lot of resource definition, and then you have controllers that are continuously looking what is defined in etcd, in Kubernetes, in the Kubernetes API, and then check what is actually happening in real life. And then this is a reconciliation loop that is continuously going on. So it's a control loop the controllers are doing to check either what's in Kubernetes and then what's in real life. And they continuously transform the desired state into the actual state. So eventually it will be what is defined, right? And that's the fundamental concept in Kubernetes with every resource. And what Kubernetes also offers is custom controllers and custom resource definition. So you can write your own resource, or you can define your own resource, then write your own controller, or as many call it, operator nowadays. You can write your own operator because it's code that you before did manually as an operator, and now it's the code is doing it. And yeah, we're using that heavily, and we also have a library called Operator Kit because we had a lot of boilerplate in each and every operator. And yes, I said you shouldn't use shared code, but we have a library for it. Yeah, and there are already kind of famous examples like the etcd or Prometheus and operator. There are even like Cassandra or Elasticsearch, Kafka operators. You find lots of them. Lots are in different states, but I think that's particularly interesting to go higher up the stack to manage more workloads on top of Kubernetes, or to have something that manages those workloads for you. Yeah, and one example is that we built pretty early on, because every Kubernetes cluster has its own CA, and you need to provide the certificates to each and every component to have mutual TLS. So we created this, the cert operator that actually looks into what Kubernetes, what certificate resources are defined in Kubernetes, and then we're using Vault, talks to Vault to issue the certificate. And then our platform operator, which is AWS operator, Azure operator, and KVM operator, would then put this into the machines, or in the AWS, encrypt this via KMS and then upload it on S3, and the machine will fetch it. Anyway, that's a good example, because the resource defines a common name, and it defines a time to live, and those kind of things that you need in the certificate, and then the operator would actually create it and store it as a Kubernetes secret. Yeah. In the end, we ended up having lots of small operators, because we believe in microservices, and we think one thing should do one thing very well, and the scope should be clear, and we shouldn't end up having a monolithic operator that manages all facets of the cluster. Usually a good sign for that is like what kind of life cycle does something have. So a certificate definitely has a different life cycle than a cluster. So they get renewed. So we decided to have a cert operator that is separate to the cluster operator that we have. And we're currently creating more and more operators. As I said, we have a library you can check out. There's also, for KubeCon there was an announcement from the Chorus people. It's called Operator Framework, and what's particularly interesting there is the lifecycle manager. That's actually the lifecycle of the operators itself, because, and we also have this. So if you have a common set of operators that manage a Kubernetes cluster, and we decided to have this tied to a version. So we have versions of every operator that are able to manage a particular Kubernetes version. So if we have a new version, then we would actually create new versions in the resources and create a new operator that is able to handle the new clusters. So if the cluster migrates, the new operator would take over the cluster and then migrate it to the new version. And but the old version is kind of immutable. It's reproducible also. So I can always start an old version of a cluster with the same management tools that were used at that point. And I think Chorus had the same problem with the Prometheus operator or the etcd operator. And so the lifecycle manager helps you doing this, running multiple operators within your system, and they reconcile different versions of your resources. It's kind of also trying to remove the complexity within the code, because we did this in the code, and this is not fun if you do this in the code. I mean, if you have a lot of ifs, it always smells, right? And then we ended up having different folders of different controllers, and no, it was not really nice. Observe your services. Next questions for...
What was the name of that operator that reconcile different versions of operator? I didn't get the name.
I think it's called Operator Lifecycle Manager or something like that. Lifecycle something. It's in the operator framework from Chorus, Red Hat. And that's the
Lifecycle Manager. Yeah.
Sorry?
Lifecycle
Manager, yeah. Other question about extending Kubernetes? Is that clear with like how that works and what you can do with that? I mean, best example is you can define a WordPress resource and give it a title and a color and a theme or something like that, and a font, and then you write a controller that would create a deployment with a PHP and a MySQL pod, and you have a particular version of WordPress running, right? That's basically an example. So next step. So for observing services, oftentimes the concept or concepts are used that have been called container patterns in the beginning. So you all know this. A pod is not a single container. It's usually multiple, and you call those helper containers a sidecar. Sometimes, depending on how they work, you could also call them ambassador. That's more like a proxy next to it, like you could call envoy an ambassador if you want to, and also there are adapters. That is like transforming an output to something that is like, for instance, if you have metrics and you have an old system that has a different way of shipping metrics, you could create a Prometheus exporter that would read those, like maybe the service is pushing metrics and then reads it and provides them as an HTTP endpoint. So that's a typical adapter. And usually, yeah, those kind of concepts are used in for monitoring. And you also have the same challenge or a similar challenge to the shared code, because if you use a lot of similar sidecars, like ambassadors next to your services, and then you have a vulnerability in like OpenSSL, then have fun rolling all your pods. But it's only rolling the pods, and you don't have to rebuild the service, right? And sometimes if you update the library, actually a team has to look over it if it still compiles and if it still works, because internally there are some structs that don't fit anymore and there are problems. But with a sidecar, it's separated. So it's an operational problem, but you don't have to give it to the development team anymore. Yeah. So yeah, first obviously Prometheus. So how does Prometheus do read metrics? You provide from inside of your service your metrics, and Prometheus collects them. And Prometheus talks to the Kubernetes API to actually discover the services, and you can define how the topology of your Prometheus looks like, and no service or no team needs to know about that. So if you decide in the first place to have one Prometheus in the cluster that collects everything, and then you at some point have scaling issues with that, you could also start having a Prometheus per namespace or per team or whatever inside your Kubernetes cluster, and still the team doesn't have to change anything. You can even have overlapping scrapes, so that really doesn't matter. And that's why this is interesting. And in the first place, all the confusion about like, yeah, we all moved to push and now we have to pull again. And why is that so? Because everybody said Nagios was bad, and you should use Graphite for pushing metrics. No, now we're pulling again. Let's see when it changes again. Yeah, it also monitors Kubernetes clusters, like the Kubernetes components itself already, it's built in. And many other components provide those kind of metrics in the ecosystem already. And yeah, for yourself, you usually use a library for that in your services to provide the metrics. But it's still, as I said, kind of independent of changes within the monitoring system itself. Also, like how you define alerts and escalations and those kind of things, and no service has to know anything about that. Yeah, and then if you want to have even more information about Kubernetes kube state metrics is definitely interesting because it gives you a lot of information about the events that are happening or the resources, the amount of resources that are running within Kubernetes to get way more insights what is happening in your cluster. Exactly, as I said, either you use a library or you have an adapter next to legacy software or third-party software that doesn't provide a metrics endpoint. Fluentd, yeah, it's actually logs, and it's not that different from how you have used your Elk stack before, maybe, or how you used other logging providers. I mean, the only difference is that the service needs to use standard out to ship the logs, so you're not using syslog or something else. So you use standard out, standard error, and Fluentd hooks into Docker and collects all the logs. That's basically it. Yeah. And then fairly new project, Jaeger by Uber. That's tracing. And as I said, if your landscape of services is getting more and more complex, you probably need to know where your requests are going and to see that for debugging purposes. And Jaeger is giving you a backend to store this kind of data and an agent that runs on the machines or in integration into your services. And it's based on open tracing, so you can get more information out of your services where your requests are going through the stack. And yeah, there are multiple storage backends and so on and so forth. And you usually start with a chart that you just run, and then you have it running in the Kubernetes clusters, and afterwards you actually have to operate it and have fun. So starting is easy, always. So yeah, that's the things you need for every service in terms of observability. And you have a bunch of libraries that you might have to use there, but still you get the point that the separation is nicely or better than it maybe was before, and that's for me the most important point here. Yeah, and now the third. Actually, I don't know if I. Let's go back what it was. The third. Sorry. Oh, come on. That was too far. So circuit breaker, authentication, identity, those kind of things. Yeah, let's break it down to communication that you need to also solve. And also a very new kid on the block that shouldn't be used in production. I tell you why. Yet is Istio, a so-called service mesh, and from my perspective, that is just Kubernetes 2.0. That's the things that are now missing. It's going higher up the stack. It totally makes sense. It's not yet in the foundation, I think. I think it was proposed, but I'm not 100% sure. But still, all the companies that are working on Kubernetes and closely with Kubernetes are also working on Istio at the moment. It's under heavy development, and it's quite interesting. And what it does, it adds a lot of smart traffic management capabilities. So if you think of canary deployments, you cannot really do them with Kubernetes at the moment. You can do them with like something like Linkerd, but Linkerd didn't really fit quite well, in my opinion. There were some overlaps with resources in Kubernetes and some replacements, and I don't know, I didn't buy into it in the first place, and I think Istio is way better. And it also adds a lot of these observability functionality into all of your services, also tracing capabilities into all your services, without you having to do something. Or maybe since the development team provides the metrics of the service, they maybe don't know what kind of metrics the network operations team wants to have from the service, right? So how can you establish those kind of standards without, again, having to tell everybody to update the library and to rebuild their services? And that's where Istio comes in. And also on the policy level, policy enforcement. So you have network policies within Kubernetes, but with Istio, you can go higher up in the protocol. You can define policies based on routing URLs, HTTP headers, whatever you want to. You can define that, and you can also do enforcement there. So smart routing and policy enforcement. And it adds service identity, so you can add authentication, authorization to your service. And it also adds a lot of new complexity to your system. Yeah, Kubernetes was already, for some people, a lot of complexity to run that in production, and now we are getting more. So Istio adds a data plane, so-called data plane, that's the lower part, and it's basically Envoy. That's a proxy that is injected in every pod. And also, all in and outgoing traffic is going through that pod, that Envoy. So the service doesn't need to know anything, but every request, every network packet will go through Envoy. And the interesting part of Envoy is that it has an interface to be configured at runtime, and you do not need to have a reload. Like, I don't know, if you have used Nginx or HAProxy, you know the problem of having a very dynamic environment and then having to reload all the time. And that's why Envoy is used here. And then Envoy adds a lot of functionality between the services. So the services don't need to know that they have mutual TLS, but Envoy does that for you. So Envoy fetches certificates and talk to each other, and or even changes the protocol that is used in between. And the service doesn't need to know anything about that. It can talk HTTP to Envoy, and Envoy does the rest for you. And also, Envoy reports a lot of metrics to the mixer, so-called attributes. So it breaks down the information it sees in every pod and then gives that to the mixer. And you can think of the mixer as a system to create your own middlewares in Kubernetes. So let's say you want to have an access log for all your services. Then you provide, what's it called? Not a plugin, but a handler for the mixer that would generate an access log for all your pods. Also, the mixer helps you with doing the policy enforcement. So you can define a policy that, I don't know, services from that namespace are not able to talk to GitHub, something like that, right? And the last thing is the pilot that does the smart traffic management. So giving the circuit breaker, if the pilot realizes that a certain pod is not available from one other pod, and then another pod starts trying to reach that pod, it would already use another instance of that service and not take the same part because it's kind of marked already that it's unhealthy at the moment. As I said, you can do canaries, so you can have like kind of a slider of having new instances running within Kubernetes, shipping the new version, and not having a rolling update where you don't have control over. So that's basically what Istio does.
I have a question. So in this case, does it act like a sidecar for the sidecars? Because how at the beginning, the communication between the service and the sidecars, you know, the sidecars did, like the ambassador or the adapter or whatever, did the work for the service. Now Envoy knows about these sidecars and also proxies these requests to the sidecars, and then the sidecars reply to the service directly, or to Envoy again. I don't get how the communication between the sidecars, Envoy, and the service happen.
So Envoy also doesn't need to know about the. I mean, it knows in which pod it's running, but it's basically IP tables. Like everything goes here. So the service and outside connections are definitely going through Envoy. That's a configuration within the network namespace of the pod. And that's how Envoy sees all the traffic, and there's no way of talking to something else without Envoy.
Right.
Yeah, and the last component is the auth component, which is actually called Citadel or something like that nowadays. And this provides you with certificates, so you can give your services identity, as I said, and you can have mutual TLS. So yeah, I'm explaining that again here. Don't have to go through that. And now the same problem again. So if you have a lot of sidecars, how do you update them? Istio at the moment doesn't provide any functionality to update itself. So you can install it, and then you have the envoys in all of your pods, but there's no way to update. And this will be provided by 1.0, and it's not there yet. So that's basically it. If you start, like, if you can run it, but you can never upgrade it. So don't run it in production.
Use Helm.
If you have to upgrade it, then
you can create a new Kubernetes cluster and then ship everything over if you want to.
and that works fine.
With Giant Swarm, even better. Yeah, that's the main thing. I mean, it's currently 0.8 or something.
0.81.
It's
supposed to come out in August, according to Google.
Yeah, let's see.
What is the problem with everything? Is it is Envoy version 1 and Envoy version 2 cannot communicate? Or is it
No, the problem is you have a kind of script to inject the envoys into every pod, but there's no script to update the envoys in the pods. That's basically it. And Kubernetes doesn't provide a way at the moment to, for instance, upgrade sidecars in pods or something like that, which could maybe be an option. Maybe Kubernetes will provide something that will make this easier, but I don't know how they are going to. So I'm not into that too much.
And if you can update the containers in the pod, what would be the problem? And then do a blue-green migration or something within the pod entity itself. What would be the problem in doing that?
I don't know. I mean, they say there's no way to upgrade, so you can be lucky and it can work, but maybe there's some incompatibility because at the moment it's heavy development, so they don't care that much about compatibility between the mixer and the pilots and envoys, and I don't know if, you know, halfway the cluster is just fucked up, and yeah.
There's still a 0 point.
I mean, I haven't done it in production, so and I haven't even tried it because they say so.
Yeah, we're using it. It's relatively stable once you install it. I mean, as I mentioned, we don't upgrade it, we just install it clusters. And we have no issue with that. But from a piece of software, it's pretty solid already.
Mm-hmm. Yeah.
It's used in a number of large-scale clusters out there. I mean, don't use it in production yet.
Yeah.
But so we're on the way to there.
Yeah, you can read all the minor posts, the Kubernetes clusters. I think there was like Tesla and some other companies that had Kubernetes clusters with miners on top. So you can run you can run it if you don't want to upgrade.
It's okay.
It's fine. At the end, I mean, the point was that a lot of these cross-cutting things, I mean, it's building a platform, and the platform provides you the right building blocks to don't have to care about a lot of things that you had to care about before without standing in your way. That's basically what I think that is important. Like compared to older paths that were kind of, you know, nice for 80% of the use cases, I think in Kubernetes you can do much more. And also how all these things play together is pretty nice. And then that's an example of how your cluster could look like, right? I mean, you have the Kubernetes masters that do all the container orchestration, and then you have your monitoring and tracing, and then you have Istio, control plane, and then these are the things that are actually on top of your nodes. You have a couple of agents running, and then you have the envoys connected to Istio. That's how basically a cluster would look like. And obviously, you shouldn't do that yourself. I mean, it's easy to say for me because we're doing that for people, but I mean, we're 25 people and we're working heavily on that, and since a couple of years already. And I still see people who say, yeah, it's easy to use kops to create a cluster. Yeah, fun. Unless you're a very strong technical company, I think you shouldn't do that yourself, and you should use EKS, AKS, or Giant Swarm, whatever. But I think you shouldn't do that yourself, and it's even getting more complex now, right? So if you look at Istio, there's a lot of complexity coming in again, and you really need good people to do that. I mean, we all like to tinker, but maybe tinkering on top is more fun than doing it yourself. Thank you. One more question?
Yeah, that was really great. Gave a broad sweep over microservice architecture with Kubernetes, and you had a small side comment, you know, with respect to extension of Kubernetes, right? And you are using it only towards infrastructure, but I think if you look at the possibilities with respect to extension API server, you know, you can actually extend Kubernetes, exactly what you said, components building on top of each other. You can build PaaS layers on top. You can build, you know, kubeless as an example, function as a service, but you can still use all the native methods like RBACs, authentication, and so on. So building on it's a fractal design, more or less, right? Mm-hmm. So I think it's not only for the infrastructural stuff, but if you think about it, it's also for business software on top. Can get to there, because if you look at AWS and Google and so on, they're doing exactly that, you know, and Kubernetes gives you a nice platform for that.
Yeah, exactly. And it boils down that you just have to run a function or a small container that has some business logic and doesn't need to know anything about all the rest of the things. And that's what I'm looking forward to. Yeah, especially with Istio, especially with, I mean, the API thing. I don't even know what kind of API gateway Istio will provide, and then how it compares to other products or the extension of the API. Yeah, that's all promising. I'm looking forward.
Just a suggestion, my team and I were doing very similar stuff to what you presented here. Mm-hmm. And when I saw the 4MD, yesterday we got rid of it and we replaced it with 5 beats. And it 5 beats actually outperforms quite well the 4MD.
We actually replaced 5 beat with fluent bit.
Okay.
Yeah, it's a constant back and forth, kind of, I don't know.
Well, we don't want too long. For whatever reason, it started to seek segmentation, seek term constantly.
Fluent D or fluent bit?
Fluent D.
Yeah, we moved to fluent bit now, which is a re-implementation. It's not Java anymore.
Yeah, it's not Java. And for bits is Golang, and it's really runs smooth.
Yeah.
Are you not running in GCP because they have the Kubernetes service?
Yeah, basically it's just demand of customers. So the people that are using GKE or want to use GKE, they already have a service that is quite good there. I mean, compared to EKS, that's a whole lot different. And so we're also looking into EKS because we can start clusters with EKS masters. As we do use CloudFormation or other AWS resources, and a lot of companies are looking into moving to AWS or also into Azure, but not that many actually requested from us to run on Google. And if they were thinking about that, they were always thinking about using GKE, and that's why we haven't. I mean, we could write an operator for it, but yeah. Didn't really make sense for us.
Now you're going to shift away from AWS because they announced that they're having service in production now. Like it's
no. As I said, it's masters. It's managed masters, and I'm totally fine with using the managed masters from because we're managing so much more AWS resources for the. For our customers, and we're managing a lot of components in the Kubernetes clusters as well. So we're managing all these agents for the customers, we're managing the monitoring stack, and we provide support 24/7 on all of those components. And if something fails, we're paged, and that's the service that we provide for our customers. So yeah, it's a lot more than just having EKS as managed masters.
Yeah, I assume they have integrated it with all their services, like the ecosystem of CloudWatch and all that stuff.
Yeah, sure. So, yeah, but then you have a single vendor black box login. And some of our customers have on-premise deployments and AWS deployments, and they have one API to create Kubernetes clusters. And the clusters are the same, exactly the same. And the services on top are the same. So that's why people like to use us. Yeah. But if somebody just buys in AWS completely and just wants to do AWS, sure, they should use AWS and all of the services there. That's totally fine. Yeah.
One question about the federation of your Kubernetes cluster. If you have your own Kubernetes cluster currently in this private cloud, then you have a deployment.
At the moment, none of the customers is really using federation. Federation was also not really there, not really good, because a lot of concepts didn't play into it. So most of the customers were fine with like geo DNS routing, kind of, because they maybe have a platform just like in front of it, like Cloudflare or something like that, and they were redirecting to the US and to Asia and to Europe through DNS, and that's basically, and they let the CI pipeline do this thing. You know, they release the service and then it's deployed and then they have to replicate some of the data as they would have in replicated server clusters anyway. So that's how people are using it. Actually, Istio is also providing some functionality in that sense. At least that was presented at KubeCon. But yeah, let's see how that overlaps and what is actually winning there. as far as the state is now, I was not really convinced of using federated clusters.
As far as I've heard, it's already deprecated again by Google, so cluster registry is supposed to be the thing to go in the future.
Yeah.
Maybe one last question before we go to pizza. What's your take? You have so much knowledge on the infrastructural side of things. What's your take on virtual kubelet? I mean, the integration of Azure Container Services and Fargate on Amazon side, kind of a black box behind the API server. What's your take on that?
I don't have any insights there. I mean, I kind of looked at it, but yeah. What's the use case?
You just insert a virtual.
You start a virtual machine with a.
No, not virtual kubelet.
Yeah.
And that basically plugs in the complete container service of the provider. Right? Have you?
I mean, I don't know. There have been many people rewriting the Docker API as well, and providing the same kind of endpoint and do something else behind the scenes. Most prominently, probably Triton from Joint, and I don't know. I mean, it's like writing TypeScript or how it is called, and then recompiling it to JavaScript. Some people love it. I don't need that, I would say. But yeah. I also use VI and not in IDE. So.
All right. Thank you again.
Great.